I'll be fine. Okay, foundation phase diagnostic assessment project. This is a collaborative project. In South Africa, there are 2 numeracy chair projects. So my colleague is Professor Melanie Graven, who works at Rhodes University. And one of the things that we were interested in and approached by the DBE to start thinking about, there was interest in the national terrain. In a national terrain in primary schools where actually we haven't had any, in the last few years, we used to have annual national assessments. And with union objections and school level objections, they went out. So the last set of those was in 2014. There is interest in national terrain in diagnostic assessments as a way of maybe getting some traction and some data in the terrain and some feedback into the learning loop. So they approached us to start thinking about assessments in foundation phase that might work to develop number sense. So it's a collaboration, as I've said, between the numeracy chairs, but also with the DBE, and a range of professional research associations on the ground, NGOs as well. So what we saw when we looked at the curriculum, it isn't that our curriculum ignores things like strategic calculating. Okay, those are mentioned in the curriculum, but I think I heard Alvin in the morning saying there's no point stipulating things in the curriculum if they're then not enacted in practice. And one of the things that we could see is that while strategic calculating, efficient calculating is stipulated in the curriculum, the assessment tasks that we could see, and certainly when we look back at the ANAs, there's no recognition of that. So while we are looking for more efficient calculation, better models, okay, more sophisticated models, when we looked at the ANAs, and Marie Vakes did some of this work in her master's, we could see that, for example, we would see examples like 10 plus 10 plus 10 as a question on an ANA paper in grade 1 or grade 2. We would see children drawing 10 and 10 and 10, counting all of them and getting 30 as the answer. And the ANA would give them 4 marks for that. Now, we were rather unhappy with that because we don't like that as the approach to working with, to calculating the answer to that question. So what we could see is a slight disjuncture between the advocacy of efficient and strategic calculating in the curriculum and an assessment regime that didn't look for that. So there's no feedback loop putting pressure on teachers to say, no, this isn't good enough, we're going to have to get progression from here. So what we looked at in this little project, this little collaborative project, was the development initially of items which are focused on what were the key early number strategies that are in the curriculum. And we could see key clusters. Bridging through 10, for example, jump strategies, reordering, the relationship between addition and subtraction, compensation, and doubling and halving. The kind of clusters of early number strategies that are mentioned in the curriculum. All of these strategies, if we look at the number sense type work, the Dutch work, for example, the RME type work, Dutch work would say all of those strategies rely on some kind of known facts at the level of rapid recall, at the level of basic fluency. So we went forward from that and said, well, what might be helpful and, importantly, what might be workable in a national terrain? And what we ended up with out of this group was, we think that there are 3 clusters of items, 3 kinds of items that need to come together for strategic calculating. One is kind of rapid recall, and we need focus in the early grades on some rapid recall, and we've got those clusters there. But we can't just do rapid recall on its own, because otherwise we get task propensity going, and we get individual facts which are disconnected from anything else. So alongside rapid recall, we need attention to what we call strategic calculating. Strategic calculating is with working with items like 99 plus 99. 99 plus 99 is not a difficult calculation if you can work with number relationships and structure. If you know the relationship between 99 and 100, that's a very easy calculation. If you're going to try column method it becomes harder. Okay? So those, we were thinking about items in that cluster as well. And then the last cluster we were interested in was something that we called strategic thinking. And strategic thinking is emphatically about what we can derive from known facts by thinking about the underlying structure. So the example there is, given that 43 plus 138 equals 181, what can we say about 181 minus 43? And we included sets of items that looked like that. So the emphasis was on doing these things together rather than saying, we'll just go for the rapid recall. So the format that we ended up with out of this project was some work with teachers on the ground which said, you have a test, we call it a testlet. It's a tiny little test. It takes about 5 minutes to run, which includes items in all these 3 categories, focused on a particular cluster. It might be the bridging through 10 cluster or the doubling and halving cluster. And you begin your 3 weeks of work with this little 5-minute test with the children in your class in grade 3. We then worked with the teacher. Well, before I come to that, the model that we were looking at was, we test at the beginning, and then you've got about 3 weeks, and we had some ideas for activities that could work in the mental starter section. The test is time limited, by the way, and that's the way we ensure that we don't see pages and pages of unit counting. So again, it's trying to work with a message underlying to teachers that this tally counting isn't acceptable. We really don't want this. So it's a time limited test. I'll show you some examples in a minute. Teachers mark the test. In the project that we began at the moment, we actually did the marking in the little trial that we did. But following that testing and following the marking, there's some guidance for what we call interim reasoning chains, which is about, we can have 8 lessons, eight starter sections work. And these are activities related to the skills being tested in that test that the teachers would work on in the interim 3 weeks. And at the end of 3 weeks, you would run a test with similar items in it again. And the retest provides just ways of feeding back to the teacher as well as to the learners on the success of teaching. If we get improvements in learning, there's a message for the teacher that the teaching has been successful. So it's a way of kind of paying attention to what's the efficacy of our teaching here. And we think 3 clusters in a term, in a 10-week block, we can probably do 3 clusters in a term. What do the little tests look like? Well, there's a page of, that's the beginnings of a page of rapid recall items, and this is the Bridging Through 10 cluster I'm showing you. You can see at the top, it says part 1, 2 minutes for this page. So it's given out to learners, and we make a little bit of a play about saying, okay, you're going to start, we're not going to give you very long, do it as quickly as you can, and we're going to tell you when to stop. And when they stop, they have to turn over the page. You can see in that first page, those are the kinds of things that we want the children to have at the level of rapid recall. On the next page, when the children turn over, little point for me, quite careful again about variations and connections as key design principles of the items. So they're not all framed in exactly the same way. That's the next page when they turn over. This is the strategic calculation items. Now you can see that's about using those early fluencies in calculations in a slightly higher number range. So there's a page of those, 5 questions on that page, and in a minute for those, run exactly the same way. Do these as quickly as you can, we're going to tell you when to stop. And then they turn over again, and there's a page which is the strategic thinking page, and these are the ones where we're thinking about the reified structural understandings of numbers. And in this page, you don't have to do any calculating at all. These are about thinking about the relationships between objectified versions of addition and subtraction, bridging through 10 examples in this case. So 67 plus 5 equals 67 plus 3 plus what? I have to be able to think about the outcome of this calculation in order to decompose it into its constituent elements in ways here where we're bridging through 10. So what we did was we went out and we did some small-scale trials across Gauteng in the Eastern Cape on using these tests. And we've got some results based on initial trials that we did. So Gauteng, which is the province that we work in and around Johannesburg, we went into 2 schools and we got, working with a teacher, with a little session, we sat with the teachers in these 2 schools, we sat with them for about half an hour, talking to them about the little test clips and how to run them, and then talking about the reasoning chain activities. And we saw some nice gains across, and you can see we've disaggregated the scores, and you've got the facilities for each item cluster are there. So we've seen some nice gains, and again, in the Eastern Cape, where we know nationally performance is lower, but again, some promising gains in terms of where children are. Now, one thing to point out is you can see from the facilities here, the facilities are much lower than, I think Kuno showed us some facilities in Holland. They're lower all round, but the gains are quite nice. So what we're doing, and what national department have said that they will look at based on this, is to do some rolling out of a national level trial based on this work, where we will do some training with district advisors, and then they will do some rollout in probably 3 provinces initially, and gathering some data on how that goes. So there's some nice work there. Once again, the point for that data today is our working with task propensity and trying to overcome that in the early and primary grades. So, just to sum up, in the South African context, why I think that work is useful and how it feeds into how we're thinking, I think we do need to resist task propensity while dealing with the need to develop well-grounded ways of solving a specific set of problem types, because we're not there. So we're going to have to do some work on that alongside working with task propensity. I think the challenge on our ground is developing practical policy messages and a language as well. It's not just messages, but a language that can be heard for practical policy, curriculum, textbook, and assessment messages to support the imperatives, if we can agree that those are the things that we believe in. So how are we doing that? Well, our project is smaller scale. I think we've got a few ways that we're thinking about. So for us, one of the messages that we use and one of the ways of talking to teachers that we've used to try and get those messages across are, we've got some key questions. So as results get established, one of the things that we pay attention to with teachers is, well, once I've got this result, what else can I say? What other results are derivable from these results? Now that's the kind of example that Kuno showed us it's a kind of Anasfard type work. It's the realization trees that would go with a particular result that's established. We've got a different kind of question which pushes in the same direction, and the second question comes from Anne Watson and John Mason's work, and their version of the question is, once you've done a set of examples, what's the same and what's different across these examples? And again, that's pushing into structure and generality rather than focusing on individual tasks. And a version of the question that Mike and I have been working with is, given a terrain which is highly procedural in its orientation, is a question which says, well, what kinds of examples will this model or this tool work for? And that's in a terrain where the children are getting on top of some basic rules, but paying attention to the example space for which that rule might work. So we're working with those kinds of questions to push against. If we're going to do that with teachers, we then have to think back to instruction. So alongside that, one of the bits of work that we've done is, well, how do we speak to teachers about the kinds of maths teaching that we value in ways that might counteract task propensity? And this is a little part of a framework that we've developed to think about, to explore the nature of teaching and to look at changes in teaching over time. And it's about building mathematical connections. And you can see at the lower end, you've got disconnected, incoherent treatment of examples. And we see that on our ground. We see that sometimes on our ground. And we also see the issue that Kuno talked about, which is every example treated from scratch. Every example treated from scratch is already one step better than incoherence. So we have to grant that, and it's building from if we're going to build from the ground, we have a little trajectory that is building upwards. But going one step further than that is when teachers start to connect between the examples. All the artifacts, all the inscriptions, all the episodes that they're working with. And we're saying to teachers, in sharing and explicating a trajectory, we're saying that these are the things that we care about. And at our top end, we're saying if the teacher talk and the teacher working with examples can make vertical, horizontal, or multiple connections between examples and artifacts and inscriptions and episodes, we start to get at ideas of structure and generality. And essentially, those are the things that we are saying. Our dot on the horizon is saying, well, structure and generality are mathematically the things that we care about. I think that's me done. Thank you.